Sample sizes for population means. Our objective? Determine the sample size necessary for estimating a population mean within a specified margin of error. Let's remind ourselves what we know. The margin of error is 1/2 of the width of the confidence interval. In other words, the width of the confidence interval is the margin of error times 2. We're going to use StatCrunch's t-stat functionality again. So we're going to go to t-stat, one sample, but this time we're going to choose with sample size to determine the sample size, go figure, necessary for estimating a population mean given a desired confidence level, the sample standard deviation S, and a specified margin of error. All right, so we're going to let StatCrunch do the math for us, as we have been doing here, somewhat consistently. Dr. Paul Jackson wants to estimate the mean serum HDL cholesterol of all 20 to 29-year-old males. How many subjects are needed to estimate the mean cholesterol of all the males, the population? Okay, he wants to be within but he wants to be within 1.5 points with 90% confidence, assuming that the sample standard deviation based upon earlier studies is 12.5. Okay, well, letter A. So within 1.5 points, right, means the width is twice that. Okay, the width of the confidence interval is 2 times 1.5, which of course is 3. Okay, so let's go into StatCrunch and have them do the math for us. All right, so let's go back to, we'll go into stat. We're going to choose t-stats again because we're dealing with population means, and we're still doing one sample. And now we're going to choose with sample size, and right there. And here's we are. Okay, we want to be 90% confident. So we're going to change the default of 95 to, where'd it go? To 90. There we go. The standard deviation, these are the required parameters. The standard deviation is, what was the standard deviation? 12.5. And we want our width to be 3, we said. So we're going to put in a 3, and we're now going to compute the sample size. And it says that Dr. Paul Jackson needs 190 20 to 29-year-old males to do what he wants to do. Okay, so he needs 190 20 to 29-year-old males. Okay, if he wants to estimate the mean within 1.5 points with 90% confidence. Suppose he wants greater confidence. I want to be 95% confident. Well, if he wants greater confidence, he's going to need to up the number of subjects, right? He needs to increase his sample size. And let's see what that's going to do here using StatCrunch. So we're going to go back to StatCrunch here. We're going to change the confidence level from 90 to 95. Standard deviation remains the same. The width remains the same. They did a little adjustment there. We'll leave it at 2.997. That should be fine. And we'll compute. And it says that he needs 270 subjects. If he wants to be more confident, he's going to need more subjects, a larger sample size. So letter B, he needs 270 subjects. Okay, letter C, how does the increase in confidence, we went from 90 to 95, affect the sample size required? Okay, the increase in confidence. Remember, we went from 90% confident to 95% confident, increases the sample size required. You want to be more confident? You'll be more confident with a larger sample, is what that says. You want to increase your confidence. One way to do that is to increase the number of people you are sampling, and that happens. So there you have it, sample sizes for the population mean.